Okay, so last chapter we looked at when we discussed gasoline as being made up of mostly octane. So what is octane? Aha, that's what this chapter is all about. Petroleum, building source.
You've heard this before, but it bears repeating. Carbon is the element of life. So much so that when we explore other planets, the first thing we look for is compounds that contain carbon. In fact, there was a time when we thought that carbon compounds could only be produced by living things. So early chemists called them, as we still do today, organic compounds. Scientists back then considered biological molecules to be almost mystical in origin, until 1828 when German chemist Friedrich Wöhler discovered that urea, a component of urine, could be synthesized simply by heating ammonium cyanate, an inorganic compound. That proved biological molecules were just chemicals that could be created and manipulated in the lab. Suddenly, a new branch of chemistry was born. Organic chemistry. It's like my favorite chemistry. So what is it about carbon, though, that makes it so special? Well, a lot of things. Like silicon, which we talked about a few weeks ago, carbon is in group 14 on the periodic table, and like all of the elements in that group, it has 4 valence electrons. And in carbon, those 4 electrons can bond to other atoms in a really promiscuous number of configurations to form all kinds of structures. Which is why carbon is to biology what silicon is to geology. Just as silicon forms the basis not only for sand, but also most of the rocks on Earth, carbon is the foundation of most biological molecules. Really all biological molecules, right? Yep. The simplest organic molecules are pure hydrocarbons containing only carbon and hydrogen. Hydrocarbon. And they...
All right. So, I can explain what organic chemistry is, and I can draw, identify, and name simple examples of alkanes. So what is organic chemistry? The study of carbon molecules. That's simple. The study of carbon molecules. The study of carbon molecules. It's a little bit like an architect uses basic materials to create buildings. Organic chemists will use the basic building blocks, these carbon molecules, in order to build whatever we want to build, from girls, your pantyhose, to guys, your sweatshirts. This new material that Hunter has on, really nice, doesn't wrinkle. It's all carbon. It's all carbon hydrocarbons. What is the most important characteristic of carbon, and why is it so important? It can bond 4 times. That is actually kind of rare. Carbon and silicon are the only ones that can bond 4 times, especially bonding multiple times with itself. The simplest forms of hydrocarbons are called alkanes. Alkanes. And here are some rules where all you have to do is write down the key phrases. Count the number of carbons in the longest continuous chain. And the next time we meet, you'll understand why that's important. Continuous is an important word. Then you have to learn a new way of counting. Perhaps as a kid you learned how to count in English. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or maybe in Spanish. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or maybe in French. 1, 2, 3, 4, 5. Did I say anything? Did I say anything French? It's just, you just talk silly, kind of sissified, and then you're talking in French. Or German. That's 10. If you cough, that's 10, right? In chemistry, organic chemistry, you say meth. Okay. For those of you who are fans of Breaking Bad, guess where we get the word meth from? This prefix, meth. I don't know. I never saw the show, so I have no idea how, but I guarantee you that somehow that word or that phrase comes from the prefix meth, which means 1. Eth, prop, bute, not but, bute. Pent, hex, hept, oct, non, and dec. Of those, and you have to memorize them, of those, there should be 4 that are already pretty clear to you. Pent, right? Pentagon, 5. How about hex? A hex nut has 6 sides. Oct is octopus. Non kind of sounds like 9. And then dec, a decade is how many years? 10.
The fully saturated hydrocarbons I just described are usually called by the much simpler name alkanes. The simplest of the alkanes is one you've heard of before, methane, or CH4, the main compound in natural gas. The next simplest alkane contains 2 carbons side by side, each one of them is bonded to 3 hydrogen atoms. This is ethane, C2H6, another gas, and it's mostly used in the production of plastics. If we add another carbon and enough hydrogens to fill all those spaces, we get our next alkane, propane, C3H8, also a gas at room temperature and normal atmospheric pressure. Propane is a common fuel for cooking, heating, and vehicles, as well as a propellant for everything from aerosol cans to paintball guns. And we could do this all day, adding carbons to the chain and giving each compound a name, but that would be pretty boring.
All right, let's do it. Emmy, 4 carbon chain. And by the way, whenever you see this, a dash, in chemistry, we use so many H's. And the fact is, they're not terribly important that we abbreviate these drawings by just drawing a dash. Wherever you see an empty dash, there is an H there. You can't see it because it's invisible. There is an invisible H there. All right, Emmy, 4 carbons. 1, 2, 3, 4. What is the special number name for 4? Bute. And how do we end alkanes? Last rule there, number 3. Ane. Butane. This cigarette lighter fluid. Yeah. For those of you who like to smoke nicotine, tobacco.
Obviously our favorite thing to do.
Cigarette lighter. All right, Spencer. How many carbons? 6. Excellent. Hexane is one of the minor constituents in gasoline. Serenity. Man, you guys are sharper than you look. Gracie. Oh, wait. No, that's it. Okay, so Gracie, let's actually draw these things. What is hept? Okay, in order to figure out the number of hydrogens, of dashes you'll need to use, what you want to do is double the 7 plus 2. So alkanes, it's CXH 2x plus 2. So 2 times 7 is?
14.
Plus 2?
16.
All right, so 1, 2, 3, 4, 5, 6, 7. Gracie, connect them. And then how many dashes should we have around them? 16. All right, everyone, every carbon needs to bond 4 times. So 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Are there 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. That is heptane. Isaac, ethane. How many H's? Times 2 plus 2. Count with me. 1. Octane. Ben. Oct. How many? And how many hydrogens? 8 times 2 plus 2. Count with me. For those of you in YouTube land, that was Ben counting through his hands. Pentane, Bailey. Bailey Haley. How many H's? Times 2 plus 2. Count, Bailey. Don't count through your hands. And that, my friends, are the alkanes. Now, what I'm going to introduce to you next is the fact that this is C5H12, right? But it's not the only element, the only compound that is C5H12. Check this one out. How many H's? How many carbons?
I don't really like that one.
5. Okay. And if you count up the H's, it'll be 12. These are called isomers. They have the same formula, but they're completely different structures. I'll teach you next time how to name those. It's not that hard.